Hello, this is Mr. Standerson, and in this mini lesson, we're going to talk about a ball toss, and we're going to focus on some key ideas and some main points. So imagine there's a ball being tossed straight into the air, slows down, and accelerates back downwards. There's a few things in this that we really need to pay attention to. One is that there's a constant acceleration throughout the path of the ball, and the other one is that there's no air resistance. So that leads us to a couple questions. At the end of this mini lesson, I want you to be able to answer at what point is the ball's velocity 0 and at what point is the ball's acceleration 0. We'll come back to those two questions. Okay, for this mini lesson, I really want you to imagine that you're tossing a ball out of your hand and up into the air and you're catching it back again. So it goes up in the air and comes straight back down. To help us understand this motion, we're going to draw a couple of graphs. The first graph I'd want you to consider is the position versus time graph. So I'm going to slow this motion down, and over time you can see that it goes fast in the beginning, then the slope decreases to a point where it's flat at the top, and then the slope slowly increases towards the back downwards journey. We can tell from the shape of the position versus time graph that we have a curve, and so therefore we do not have a constant velocity for the entire journey. In fact, we have some accelerated motion. We can tell that from the curve of the graph. So we're going to further analyze this by taking a look at a velocity graph to see exactly what that acceleration looks like. Okay, let's combine our understanding of the position versus time graph and the velocity. Notice it starts out with a high velocity and then it slowly goes to 0, and then the velocity increases again from 0 to the point where the ball comes back to where it was launched from. Looking at the slope of the velocity time graph, I can tell that it is a constant slope and it's a negative direction. So for my acceleration, I would have a constant negative acceleration. Now, the point that I want to make about this is this negative acceleration happens for the entire time that the ball is in the air. So even though the ball's position changes and you get farther from the origin to the maximum distance away and then back closer to the origin or where you let the ball go from, and the velocity starts at a high velocity, at the top of the arc actually reaches a 0 velocity and then it increases again. This constant change in velocity can only be due to the fact that there is a constant acceleration for the whole trip of the ball, the whole ball's journey. Okay, to summarize a few main points here. The whole trip, the acceleration was negative. And I want to make a point here that having a negative acceleration does not mean that the velocity is slowing down the whole trip. In fact, it does slow down at the first. It starts high here and then slows down to 0, reaches 0 at the highest point of the ball's journey. But keeping the same slope, the same acceleration, as soon as the ball changes direction, it is now starting to pick up speed. The velocity starts low here and then increases throughout the rest of the ball's journey. The acceleration sign is merely an indication of what direction the acceleration is. In this case, the direction of the acceleration is downward for the whole trip of the ball. The last point I want to make is it's easy to assume that acceleration and velocity are always going to match each other. But keep in mind that velocity is not the same thing as acceleration. Acceleration measures a change in velocity, so it's going to describe how the velocity is changing. In fact, when we look at our green line here, we're changing at a very uniform, constant rate. That's why the slope of this line is a constant slope. It's describing how the velocity is changing over this time interval. It's not saying what the velocity is. So acceleration and velocity are two different things. Okay, so this brings us back to the questions I had in the beginning of the lesson. I'd like you to reflect on these two. At what point in the ball's path was the velocity 0? And at what point in the ball's path was the acceleration 0? Hopefully by now you're seeing that at the ball's path where the velocity is 0, that is going to be where we are basically changing directions. So we're going from a positive velocity to a negative velocity. So if I graph this really quick with a sketch, starting high, going low, the point where it's 0 is right where it crosses that origin. That happens to be the highest spot in the path. Okay. At what point is the ball's path? It is the acceleration 0. Hopefully you also took a look at the graph on the last line and you notice that the acceleration, if there's acceleration in time, the acceleration graph was a constant line the whole journey. So this is a trick question. There is no point along the path where the acceleration is 0. Thank you and have a great day.